Dear students, I am Dr. Roseline, Assistant Professor, PG Department of Computer Applications, St.Joseph's College of Arts and Science, Cuddalore. Now I am going to discuss about the hardware concepts in distributed operating system. The classification of distributed system is based on hardware and also it is based on number of instructions and data stream. First, we'll see the classification based on hardware. All distributed system consists of multiple CPUs and we'll see how these multiple CPUs are interconnected with each other and communicate with each other. The distributed computers are classified as tightly coupled and loosely coupled. The tightly coupled systems are nothing but multiprocessor with common shared memory. These multiprocessors are classified as bus-based multiprocessor and switched multiprocessor. The next category is loosely coupled, which is nothing but multi-computers with its own private memory. These multi-computers are classified as bus-based multi-computer and switched multi-computer. First, we'll see about tightly coupled OS. This tightly coupled OS consists of n processors which shares common physical address space. Communication can be done through common shared memory with the help of bus network. The next one is loosely coupled OS. In this loosely coupled OS, each processor has its own local memory. Communication can be done through message passing with the help of bus network. Now, we'll see the difference between loosely coupled OS and tightly coupled OS. In loosely coupled OS, each processor has its own local memory, but in tightly coupled OS, the n processors share physical address space. In loosely coupled OS, communication can be done through message passing, but in tightly coupled OS, communication can be done through common shared memory. The loosely coupled OS manages heterogeneous multi-computer distributed systems, but the tightly coupled OS manages multi-processors and homogeneous multi-computer. The loosely coupled OS is similar to local access field as a non-distributed standalone OS, but the tightly coupled OS provides local services to remote clients via remote login. The loosely coupled OS uses data migration or computation migration modes, but the tightly coupled OS uses data transfer from remote OS to local OS via file transfer protocol. The distributed operating system is considered as loosely coupled OS. Here, the network operating system is considered as tightly coupled OS. Now, we'll see the classification based on instruction and data stream. This classification is called as Flint's classification, which is classified based on number of instruction and number of data stream. The Flint's classification is divided into 4 types. The first one is SIST, that is single instruction stream and single data stream. The next one is SIMD, single instruction stream and multiple data stream. The third one is MIST, multiple instruction stream and single data stream. And the last one is MIMD, that is multiple instruction stream and multiple data stream. First, we'll see single instruction stream and single data stream, which has one program counter and one path to data memory. A computer is capable of executing one instruction at a time, operating on one piece of data. An ordinary computer is considered as single instruction stream and single data stream. This method has one CPU with one instruction and one set of data. The next one is single instruction stream and multiple data stream, which has one program counter and multiple paths to data memory. A computer is capable of executing one instruction at a time but operating on different pieces of data. This stream has multiple CPU with one set of instructions but with multiple sets of data. This is known as single instruction stream and multiple data stream. The next category is multiple instruction streams and single data stream. No more existing computers fit this model. This is known as uncommon architecture. No computer is using this particular method. The last one is multiple instruction stream and multiple data stream. A group of independent computers, each with its own program counter, program and data is known as multiple instruction stream and multiple data stream. A computer that can run multiple processes or threads that are cooperating towards a common objective. In this category, which has multiple CPUs with multiple sets of programs and multiple sets of data. Now, we'll see the hardware concepts of distributed system. The distributed system is nothing but MIMD, which is again classified as tightly coupled and loosely coupled. Tightly coupled is nothing but distributed system and loosely coupled system is nothing but LAN network system. This is the taxonomy of distributed system. This is nothing but MIMD, which is again classified as tightly coupled and loosely coupled. Tightly coupled is nothing but multiprocessors, which is again classified as bus-based multiprocessor and switched multiprocessor. Similarly, the loosely coupled is nothing but multicomputers, which is again classified as bus and switched multicomputers. Now we'll see the definition of bus and switched. Bus is nothing but a single network which is designed using backplane, bus, cable or other medium that connects all machines. The cable TV is the example for bus network. Switched is nothing but which is designed individual wires from machine to machine with many different wiring patterns in use. Here the message can be passed from machine to machine. The routes can be changed by using switches. The worldwide telephonic system is the example for switch network. So already we have seen the distributed system which is considered as MIMD. This distributed system is again classified as multiprocessors, which is again classified as bus-based multiprocessor and switch-based multiprocessor. The next category is multicomputers, which is nothing but bus-based multicomputers and switch multicomputers. We'll see one by one. This is bus-based multiprocessors, which consisting of multiple CPUs with a common shared memory, which is connected through the common bus system. This is the next category, which is nothing but switched multiprocessor. A crossbar switch and omega switching network is the example for switched multiprocessor, which has multiple CPUs and multiple memories. The crossbar switch is designed using n CPUs and n memories and which has n square cross-point switch. For large n, this number can be prohibitive. Hence, an alternative switching method is required, which is called as omega switching network, which has n CPUs and n memories. The omega network requires log n to the base 2 switching stages, each containing n by 2 switches. Hence, for a total of n log n to the base 2 by 2 switches are required. So, comparatively, the omega switching network is better than the crossbar switch network. The next category is multicomputers, which is classified as bus-based and switch-based multicomputers. First, we'll see about bus-based multicomputers. In this category, each CPU has direct connection to its own local memory. This method is easy to build and communication volume is much smaller and also it has relatively slow speed LAN. This is the design of multicomputer which has multiple workstations which is connected through common bus. The next category is switched multicomputers. The switched multicomputer has direct and exclusive access to its own private memory. The switched multicomputers are classified into two types. One is grid network, another one is hypercube. The grid network is easy to design, which is nothing but the PCB layout. This is suitable for 2D nature problems. The example for grid network is graph theory. The next category is hypercube, which is n-dimensional cube. Each CPU has n connections to other CPUs. Here, the message passing is easy because of nearest neighbors are connected. This is the design of grid network and this is the design of hypercube. Thank you.